Okay, this video is for a Giovanni Lombardo. I hope I didn't say your name wrong. And a few others that asked me how my circuit works. It's basically a ZVS driver. So I drew a little diagram here. A couple things I wanted to go over. These diodes here, you have to make sure that these are fast recovery diodes. You try to use a normal diode, it'll be too slow, it won't work. So that's very important. The 12 volt Zeners will do well as long as you don't put in more than 30 volts. If you plan on putting more voltage in, you might want to change those to 15 volt Zeners like I did. But this is just basic. And then your make sure you have an AC capacitor. Now I've got, make sure you use these kind. These work a lot better. Or I use fan capacitors. Seems to work the best for me. If you try to use those little red capacitors like these, it'll work, but it won't do so well. You won't get as big of an arc as you would with the yellow ones like this. Your toroid cores, make sure they're high quality, and that's pretty much it. And if you plan on inputting more voltage than 30 volts, you might want to change these 470s, these two resistors on the inputs, to 1000 ohm. The MOSFETs I used are, let me see, IRFP 90N20D. These can handle 94 amps at 200 volts, or basically like the 260s, only they can handle twice the current, and they have a 30 volt gate, which helps. And see these little ferrite beads right here? If you put those on the gate of your MOSFET, those will help tremendously in absorbing parasitic oscillations that can damage the gates of your MOSFET. This is like the weak point of your MOSFET that you want to protect. That's what all this is for. The Zener diodes, it's to protect the gates. So just if you want, snapshot that. That's my circuit diagram. And wherever you see a curved line here, that means it jumps over. The two lines are not connected. Okay, and wherever you see a dot, those are connection points. Alright, and then it goes up, you do 5 turns on your flyback, and then you'll have the thick red wire, and then usually the third pin over ends up being your negative. So, this is what I use to power my Tesla coil. And that's what it looks like once it's put together. You can see I got the fan capacitor, the two toroids, fast diodes. And another thing, if you want, this is optional, you can make an isolation transformer that goes to your flyback. Just in case the flyback fails, you won't burn up your ZVS driver. The oscillations will continue in here. Basically, this is just copper strips, 6 turns on the primary, 8 turns on the secondary. You can see the secondary is a little bit wider. And not only does that isolate, but it also steps the voltage up a little bit. So let's go ahead and see this thing in action. That's the Tesla coil that I'm powering. I can turn it on just to show you. Just gotta go ahead and hook up my power supply. It's battery powered. bring this a little closer. Okay. Positive, negative. Okay. All right, watch this. As you can see, it works really well for driving a Tesla coil. And that's pretty much it. I hope this helps. If you have any questions, just leave them in the comment section.